Okay. We are ready to go, Esther or Anan?
Yes, we're ready.
Oh. Okay. Welcome and good morning and good afternoon, depending on where you are. This is the PINFA webinar on how flame retardants combine fire safety and sustainability in automotive plastics. So welcome to our first PINFA online webinar. We have done 4 events previously on automotive topics for flame retardants, 3 specifically on electric mobility. And we did them in Shanghai, in Tokyo, and in Darmstadt, Germany last year. So welcome. This is a timely topic, and in this webinar, you'll learn about more why orange is the new black. That's also why I'm dressed up like this. And you'll learn about the battery barbecue test, as it is called, a new test from China. And perhaps you will also learn why the inclined plane may reduce the pain of the CTI testing, but more to that later with our speakers. Why is flammability an issue for electric mobility? Well, cars do burn occasionally, not only electric cars, but also gasoline or diesel-powered internal combustion engine cars do burn, and there are, for instance, in the US, more than 200,000 vehicle fires per year. Electric cars don't burn a lot more than regular cars, but they burn occasionally, as I said, and they burn in a different way. They're much harder to extinguish, even leading to the fact that sometimes the fire brigade has to dump the whole car in a container of water to get the battery fire extinguished. We also have new challenges like very high voltages and currents that pose a specific risk. And all this has specific challenges for materials that are used in these cars, not only in the cars, but also in the charging infrastructure, which will also be covered in this webinar. So that's what you can expect of today's event. But before we come to the actual presentations, a few words about PINFA and housekeeping. So first of all, my name's Adrian Beard. I'm the chairman of PINFA. PINFA is an organization, it's a sector group of CEFIC, the Chemical Manufacturers Association based in Brussels. I work for Clariant as head of the marketing team for our phosphorus-based flame retardants, and I'm based near Cologne in Germany. And my background is actually in environmental sciences, but that's a long time ago. So if we go to the next slide, as this is a meeting of industry participants from also competing companies, we need to do this reminder of adherence to competition law, antitrust law. So we must not talk about prices, customers, regions, and so forth that are relevant in the terms of antitrust or competition. So be vigilant if such a topic should occur and alert us, but I'm not concerned that this would happen today. Just some housekeeping rules for the webinar as such. So please mute your microphone if you're not speaking. Please use the chat function to raise your questions. The question and answers is scheduled after we have run through all the presentations, and that will be a moderated Q&A session. And as I just mentioned, no questions on pricing or production volumes because that would contradict antitrust rules. If you have technical issues with the meeting software connection setup, we're afraid we cannot help you in that respect. You need to contact your own IT support. And information for all of those who have joined. The event is recorded because we want to make also the recording available for participants who couldn't join at a later time. Yes, now who's PINFA? PINFA is the Phosphorus Inorganic Nitrogen Flame Retardants Association. We have 28 members who are manufacturers and users of these three major technologies of non-halogenated flame retardants. We are more than 10 years in existence, established in 2009 as a sector group of CEFIC, the European Chemical Industry Council. And we also have branches in North America and China, formed in 2012 and 2018, respectively. And on the next slide, you see our membership encompassing big, well-known chemical companies, polymer plastics companies, but also smaller specializing companies. And what is particular about this industry group, that it not only combines the producers of flame retardants, but also downstream users, compounders, processors of flame retardants, our flame retardant customers. And also this webinar is meant to address the whole value chain. So from the flame retardant producer over the compounder up to the part producer, tier 1, 2, 3, and even OEM, final end user of flame retardants, in this case for electric cars. And here you see your PINFA contacts. Besides me, you see Esther, who's our General Secretary, and Hanan, her assistant, both based in Brussels. And I have two vice chairs, Michael Klimes and Thomas Futterer. And here you see how you can contact us or follow us. Of course, we have a great website, pinfa.org, but we're also on LinkedIn and on Twitter. And I forgot to mention that was on the first slide that the hashtag for this event and these activities is hashtag eMobilityPinfa in one word. So if you want to follow us on this topic or want to post something about the event today, please feel free. Good, and now it's the point to hand over to the moderator of this morning session. It's Antonio Nerone. He graduated in nuclear engineering. Surprisingly, he found his way into different areas of work, has worked on polymers for many, many years, more than 30 years with DuPont, and he's now with RADICI as market expert for electric and electronic applications. And with that, I hand over to Antonio to moderate and take us through this morning session.
Thank you very much, Adrian. So today you can see the agenda is quite a dense agenda of topics, and as was mentioned before by Adrian, there is the first speakers will be Mr. David Chi from RADICI in the morning, and myself in the afternoon, talking about e-mobility solution for today and challenges for the future. David is an engineer, graduated at Tongji University in Shanghai in 2007. Then he started working at Total as a sales manager, and then went, as you can see here, through various positions and joined RADICI in 2016. And actually, he has the role of marketing manager for transportation, automotive into RADICI. The second speaker the second topic is going to be presented by Dr. Wagner from UL, and is going to present the new standard to ensure for safety of electric vehicle in general. And Dr. Wagner has a PhD in chemistry, as you can see, and he has experience of at least 14 years in, let's say, engineering operation roles. And today is the business automotive manager at UL. Next presentation will be about new reliability and challenges for electronic components. Is going to be presented by Mr. Franz Janssen, Mr. Jansson is a long experience into company TE, and he started in 1997 as engineer in design team. Then he went through different roles inside TE company, and now he has the role of the global release manager for all the materials into the automotive segment of TE. Next speaker is our two speakers from company Schneider Electric, who is very well known to be a market leader in electrical devices, and Mr. Nicolas Dupont and Mr. Laurent Tribut. Mr. Dupont joined Schneider Electric 5 years ago. He has a degree in mechanical engineering, and he spent various roles, but his latest roles here have been into the let's say design of the electronic cars and for the wall box charging stations. So actually he covers the role of leader into the continuous engineering for the electric vehicle charging stations and all the related issues. Having said that, the last speaker is going to be Adrian Beard. As you heard, he already introduced himself quite well, so I'm not going to spend any other word except saying that Adrian Beard is, let's say, actually covering several roles and is very active into the flame retardant activity, and he's definitely today his role, he has the double cap of being the marketing manager at Clariant for the flame retardant systems, and as the let's say head of PINFA Association. Needless to mention that Adrian Beard has a degree into chemistry, is a PhD in chemistry. And now we can start with, let's say, the presentations. So as I said before, presenter is Mr. David Chi, who is going to present e-mobility solutions for today and challenges for the future, particularly with a focus on, let's say, Chinese standard. And David, now you can start your presentation.
Thank you, Antonio, and thank you, Andre. I'm sharing my screen right now. Can you see my screen right now?
Yes.
Okay, perfect. Okay, good morning and good afternoon to everyone. My name is David Key from RADICI, China. I'm responsible for the marketing and also business development of the automotive industry, and also I'm also responsible for the CAE analysis in China. So my today's presentation is e-mobility's RADICI solutions for today and also the challenge of the future. And here's the content of my presentation. Firstly, I would like to introduce you about the RADICI group, and then we can discuss about our solutions in the new energies vehicles industry and also the challenges that we have been confronting recently and in the future. Okay, the first part is RADICI Group. RADICI Group is an Italian company founded in 1920, and then in 1960 and 1980, we started the polymerization of both PS6 and PS66, which are widely used in nowadays new energy vehicles. And then in 2011, we start the polymerization of long-chain polyamide, which including the PS610 and PS612. And this is also very new trend in the future, because if you consider about the global warming affections, a lot of companies recently start the usage of the bio-based polyamide, which is PS610 from us. And then in 2013, we launched the high temperatures polyamide, which is HHR and also Nextring. HHR is PA66 and PA6 copolymer, and next stream is a PA66 and PA6T copolymer, which can be used for the temperatures up to 190 degrees C and 230 degrees C. And in 2016, we launch a new brand, which is a special polyamide-based materials, and this is very high stiffness polyamide, which can be used for the chassis to replace metal, and also for the removable batteries brackets. And here's our portfolio, product portfolio. So we are RADICI Group covers almost a very wide range of polyamide, but just excluding the PA6 to PA46 and PA11 and PA12. And besides that, we have covered almost every polyamide product in our portfolio. And besides that, we also supply the customers with one-stop solutions, which including the PPS, PBT, and ABS, POM, and TPEE. But also we are having a quite experience about flame retardant materials, including the polyamide and also the PBT. So now we are going to the second part of my presentation, which is the challenges of the materials in the future of the new energy vehicles. As you can see here, I summarized mainly 4 segments of the challenge. The first one is the contact corrosions. Here you can see that the metal part was hybrid injected with the plastics ones, which is flame retardant polyamide. But if the polyamide flame retardant additive is not right chosen, then you will confront this contact corrosions phenomena, which is very dangerous for this kind of electrical or electronics devices on the new energy vehicles. And besides that, we also has been required by our customers for long-term constant color performance, which you can see here. The original color is RAL 2003, but after heat agings, it's hard in the past to maintain these color stabilities. And this is very, very important. And then I would say in the future, there are 2 aspects of in the past that the customers were not focused, but nowadays we have been requested constantly and seriously by the customers to pay attention to the volume resistant and also the dielectric strength after heat agings. And you can see here, this is our polyamide 66 filled with 35% glass fiber V0 grade, which is halogen free and also red phosphorus free. But you can see here, after the for the different temperatures, this volume resistant will be dropped very quickly, and this would be very dangerous for the part to be, let's say, if the part suffers at very high voltage, then this part will be penetrated by the high voltage. As also for the dielectric strength, when it drops up, it also affects the performance of these electronics devices on the new energy vehicles. And nowadays, we are cooperating with our customers, including the OEMs, try to establish a new specification, try to control these materials on these 2 aspects. So this, I would say, is a big challenge for the future. And here I'm going to share you about the new challenges within China territories. First one is the charging technology. As you can see here, in the past, we have these traditional charging systems, which are using a very low or you can see moderate voltage, which is 220 voltage, and the currency is 200 ampere. But nowadays, as you can see here, in 2015, China government launched these new national standards to use high power charging systems, which is using 1000 voltage and also 500 amperes. This is quick charging systems, but also for this high voltage, you need to pay attention to the resistance of both volume and service of the materials to avoid the electron charges accumulation to bring up these static problems. And in this May, China government launched these new regulations, national standards for the electrical vehicles wireless charging. This is a charging system for the vehicles, not for the mobile phone. And this is also a new trend in the future. Now, for this standards is not fully established yet, and we are cooperating with several tier ones and also the OEMs try to fulfill this materials request within these regulations, because this part needs to be generated the electrical magnetic field, and you need to pay attention to the materials with much lower resistance and also higher dielectric strength, because this could be affecting this electrical magnetic field to affect the charging performance. And besides that, as you can see here, in 2015, the China government issued these national regulations, GB/T 31467. This is a new regulations regarding to the battery pack. Within these regulations, there are fully 40 items tested for the battery pack. But within them, the most severe test is the fire test here. You can see here. Normally, the basic ideas of this test is put the battery pack 50 centimeters above this pan filled with gasoline on fire, and put this battery pack on this fire for 70 seconds, and then move these fires away. If the battery pack is catching fire, this fire should be self-extinguished within 2 minutes. And this is very severe. Normally, till now, I would say the plastics battery pack housings, no one can pass this test. But fortunately, within RADICI, we cooperate with our customers. Now we can pass this test. As you can see here is our test videos with these top covers made with PSX 30% glass fiber V0 grade. In the past, the customers use PSX 30% glass fiber V0 grade, but nowadays customers want to want for the cost reductions. So we move from 6 to 6 solutions. Now we can also pass this test for the customers. As you can see here, this test review. Okay. And then I will show you the third segment of my presentations, which is our applications of the new energy vehicles. As RADICI, we have been investing on the new energy vehicles for quite a long time. Here is the data. I'm showing you that we are working with Renault in 2011. We found out this is the boom tables for 3 types of vehicles. The first one is 1.5 turbulence diesel engine, and this is the second one is 1.6 turbulence gasoline engine. And this one is 1.5 hybrid vehicles. And these materials are the material boom within only the powertrain systems. And you can see here very interesting trend is that firstly, the metal usage for the powertrains of the hybrid vehicles, which we call new energy vehicles, has been sharply decreased for the weight reduction for sure. And you can see the PP materials has been decreased for sure. But for the polyamide and the PBT materials, usage per vehicles on the new energy vehicles has been sharply increased. So that is why we are trying to invest in the past. And for sure, for the new energy vehicles, there are 3 core systems: e-motor, battery, and e-control systems. And here's the e-control systems we are commercialized with our customers for the PDUs and the PCUs. If you open the PDUs, for example, you open it, you can see a lot of bars, or you can call it the junction box, which are using quite a lot of polyamide solutions, which is PSX 25% glass fiber V0 grade. Here's the 3D designs of this part, and here's the real part we mold with our customers together. And this is already commercialized. And besides that, within the batteries, we also have several parts, which is here you can see these battery assembly modules. On these areas, we help the customers to integrate these 2 metal parts to be on one single integrated plastics part. which is using 6.6 filled with 50% glass fiber to bear vertically to 20,000 newtons without any deformations. And here's the bunched batteries from our customers. As you can see here, these two pinked part is using PA66 25% of glass fiber V0 grade. We also commercialize. And this is the very famous BMS, which we call the battery module management system, which is also using PA66 25% glass fiber V0 grade. For these two parts, as also the PDU parts, as I mentioned in the past, the customers only considered about the contact corrosions, but nowadays the customers also requires the very stable, let's say, volume resistance and also the dielectric strength on these parts, which can possibly infect the functional of these electronics devices within the new energy vehicles. Okay, so I would say this is my presentations for today, and I will transfer to Antonio again. Thank you all.
Thank you very much, David, for the very interesting presentation. Now next speaker is Dr. Thomas Wagner, who is going to introduce us, as we said before, about the new test standard to ensure fire safety of electric cars. And as you know, UL is one of the most important certification for the bodies in the world, particularly as long experience with flammability related issues. And so we are really ready to listen to Dr. Wagner about UL presentation. Thank you very much.
Thank you very much for that kind introduction. At the beginning, Adrian referred to reducing the pain by using IPT technology. So I'm not sure if my presentation will reduce pain, but at least I will show what IPT means, and we will see some pictures around that. Thanks for that introduction. We have seen already some applications in the first presentation. The presentation now is more focusing on the testing side of it. Do you see the screen and do you hear me clearly?
We can hear you, but don't see the screen.
So the screen is not sharing correctly?
No.
Okay. Is it working now?
Yes.
Okay. So the next round about 12 minutes is about the testing around e-mobility applications. We will see a brief overview of the things we can do with materials, all type of materials. And the agenda is a pretty slim and short agenda with a view to the time frame we have today. So first of all, I will start with the component-based testing technology, considering all the assemblies and the component groups in the cars. The second part, and this is the bigger one, I will give an explanation of some basic test standards for e-mobility applications, some historical things, but also some developments into the new future, into the new reality. So when you look at that picture here, this refers to a vehicle, a generic vehicle, in this case a combustion vehicle, and we see that you actually can separate many of the polymer parts in this car into different groups. So for instance, the seating materials, the materials for internal applications. When you look here at the fuel systems, which are still mentioned, this is the only group which will really disappear. Most of the others will stay there. So this means the testing technologies we are using, they are there in the past, they are here in the present, but many of those will be there also in the future, maybe adjusted to the new requirements for the e-mobility. Today, the main focus is flammability and fire testing of materials, which is around UL94 and many other testing technologies. Of course, with the e-mobility background and the battery application, many of those flammability test standards are being expanded outside of the interior compartment, which was the beginning of flammability testing. We have already seen in the application-oriented first presentation that V0 materials play a big role in the market at the moment. UL is actually doing the standardization for this flammability test, and there are different categories for it. You see here a very simplified picture of the UL94V test. And this test procedure here is the basis for all the ratings we talk about today. I always mention here, it's not that UL is instructing raw material suppliers to use V0 materials. We are supplying the test standards. We are giving you the tools and the results to classify your materials. And therefore, I made a red comment here. A V0 material is, of course, a high-price material. It's a high-performing material, but it does not replace the design of a smart battery cell. So with the best material in the world and a very bad battery cell design, maybe our application will fail as well. So V0 is not the solution for everything. That's the key message I want to submit here. And UL is supporting our clients, you, of course, as well, to classify your materials accordingly. We suggest when you start a basic material evaluation to start with UL94 testing for first start, because it's simple and quite easy to do. Going more into detail, you see here a flammability test done coming from the interior world, the historical world. It's called FMVSS 302, and there are many subgroups coming from the OEMs using this. It's actually a horizontal burning test, which was originally designed for interior parts to classify burning time, burning path, and burning rate with the corresponding rating. In the meantime, and you see that on the right-hand side in this presentation, we are expanding that to other applications which were actually not foreseen in the past. On the right-hand side, you see a display, and of course, you look how the flame progresses, how flames damage the component assembly completely. And of course, this is an assembly including glass, including elastomers, including polymers and metals. This side here, and this is the glow wire test, which is a very important test to simulate malfunction electrical components. So compared to the flammability tests with open flame, here you have a source, an energy source, which is a glowing wire. The principle is you actually have the glowing wire penetrating your material, you get in touch, and you look at the material, how it behaves. You do that in different steps, 50 Kelvin steps, and then you actually classify the material accordingly. You have failure criteria. On the right-hand side in that presentation, you see a sample which was melting in this case. There was a hole formation, of course, and some of the material was flowing down. And you look at the time the material is burning after the test. And once again, this is for sure a good basis to classify materials for connectors, for plug-in systems and stuff like that, because you need to know how those materials behave when you have a misuse, a malfunction, or something which is not normal in the application. And this glow wire test is also a historical test, which is also now being transferred into the new world of e-mobility. And we see a big rush for this test, especially coming from the e-connector industry. So Adrian talked at the beginning about the comparative tracking index test, the CTI. This is one of the key tests which is actually embedded in the so-called UL yellow card. So this is for sure a basis to select your materials for electrical applications. You will always see the CTI. Historically, this one is coming from the electrical industry, and it was designed for a range from 100 to 600 volts. Increased by 25 volt steps. You see a very rough picture here on the right-hand side, a lot of smoke around. Basically, these tests operate with two electrodes. You apply a voltage and you create a current flow in between the electrodes on the surface of the material. And here, at that point, the characteristics of the material come into the game. It's the water take-up of the sample, the conductivity, electrostatics, and things like that. As I said, a historical test designed up to 600 volts. In the meantime, our clients consider 800 volts, 1000 volts, and so on. On the electrical side, it's not so difficult to scale up, but actually on the conduction execution side, you will see sparking and stuff like that. And therefore, UL is working on a new CTI test setup with modified electrode orientations and geometries. to at least find some comparison with the historical values up to 600 volts. And I'm pretty sure this will be part of quite a lot of question and answer sessions later on. The last test, and this is now the reducing pain test, if you wish. This is the inclined plane taking test, what you see here. This design is actually already considering very high voltages, up to 7 kilovolts. You see that the electrode design is now different. The path in between the electrodes is much bigger compared to CDI, but you have once again the principle that an electrolyte is flowing in between the electrodes, and you analyze the material behavior in between. Of course, typical failure criteria like burning samples, formation of holes, tracking path length and stuff like that are considered here. So for the time we don't have the new adjusted CTI test. IPT can for sure be a replacement, but we need to be sure and clear that IPT results cannot be directly compared to CTI result. It's an additional information, it's a different test, and there is actually not much overlap with older experiences. So I would say let's also use this for the discussion later on, how we can develop electrical testing on materials in the future. And that's already the last slide I embedded in my very slim presentation today. So I would say thank you at that point. I will stop screen sharing and I think we can continue with the next presentation, and I'll give it back to the moderator.
Thank you very much, Thomas. This was really a very, very fast overview, and thank you. This will probably help us to have more time for the question and answers, because you raised a lot of very interesting points. And let's say after having heard a plastic manufacturer, after having heard let's say certification body, now the next presenter, Franz Jansson, is from a first or second tier, so one of the companies who is really facing the problematic of designing and producing materials and parts able to fulfill the requirements of the customers, of the OEMs. So now let me give the speech to Mr. Franz Jansson from T Connectivity. Please, Franz.
So hello to everybody. Thanks, Antonio, for the short introduction. Does everybody see my screen?
Yes.
Okay. So in my presentation, mainly I like to be focused on the connector side, where we have a lot of requirements to fulfill for the new applications on e-mobility. We are focused on different components which we produce for the market. We produce HV connectors. We produce also some connector parts for the charger. If I like to go for the next slide, something is not working, why ever. The presentation, I'm still connected, yes or no?
Looks like you are connected, Franz.
Sorry. Show my computer.
Yes, we still see the title slide, Franz.
Yeah. But I could not go forward, so something is wrong. So I need to connect again myself, why ever.
Now it moves.
Now it's working.
So I'm not sure why. So I try to be relaxed. So the agenda content, I'd like to introduce the company shortly, my main function behind what I do in the company. The next topic will be, I'd like to go over high voltage requirements, which kind of impact do we see by selecting flame retardant materials for design for a molding process, difficulties and challenges, what we see on the material developments. We have already some materials in place which are robust enough to pass the requirements on the test validation according to our customer specification. And the last point will be conclusion and outlook. Maybe I need to address also some questions to UL from our side later, but we will see that. So coming to the short introduction of TE, we are divided in different sections in different regions on the globe. So we are present in America, we are present in EMEA, we are present in Asia Pacific with different engineering offices and the amount of engineers behind. The main section on our sales is transportation, which is covering the automotive business, also ICT, sensors and infotainment. The next box will be industrial, based on the sales which we had in 2019, and last but not least, also the communication platform. Coming to the solutions with which we place on the market, you see there that there are different market segments where we are in. Again, transportation is one of the biggest boxes. And with that, we like to give solutions also to different technologies, and therefore we have different technologies platforms placed over the world. So the second main important platform is industrial, the third one communication at the end. Coming to the topic of high voltage requirements in our product design and process, I like to go over and product portfolio, reflecting the terminal connector side, which is designed according to the automotive industry, mainly focused on the OEM structure according LV2114. So there the main requirements are described. We have a different portfolio where we start with simple parts like covers, where we go for sealed connectors, potentially we go for miniaturization, headers, sensors, inductive systems, infotainment, high voltage application, and seals. So we have a different product portfolio, and behind that different requirements are to be solved from the material side. Moving to the high voltage application today, we see that requirements are moving. We are focused much more on flame retardancy, we need to be focused on different standards, test standards, and as already mentioned from the speaker before, we need to be focused on UL 94 standards, mainly on V0 requirements. Then based on that, we have the CTI measurement. Based on the CTI measurement, we have some design rules according DIN AN 60664-1 or VDA. Depending where we are in, also inside of the car, we go for requesting materials which are fulfilling standards according to the FMVSS 302, or Y ignition test, and GWFI requirements. As already mentioned before in the former presentation, today we mainly select materials which are fulfilling the CTI 600 volt standard because there we have test standard in place, we have the design standard in place, and we know how to define the creep distance from contact 1 to contact 2 based on this CTI test method. Our customers, they request us for materials over 800 volts up to 1000 volts, but I think also between the CTI test method and the design standard DIN AN 60664-1, that we need to conclude, do we go still for this design standard, or if we improve the CTI test method, as already mentioned before, what is the conclusion for our design? So I expect that if the test method will be adapted, or there needs to be adapted, that we need to speak also with the customers and OEMs and norm standards for improving also some of the topics in this DIN AN standard, potentially, if there's an impact or not. Yeah. So today, taking some results out of the market based on the CTI 600 test method, we see that some of the materials, they pass the values up to 550 or 650. If you go for improved materials like PPA ones, independent how they are modified, we could achieve 600 volts up to 800, 850 volts. Maybe the measurements are not stable enough due to different reasons already mentioned before in the former presentation, but there are some indications on the market available that PPA materials are better candidates if we take the actual test method and we go up to 800 volts, max 1000 volts to be visualized also in the future. Then the second topic, everybody's asking for flame retardancy. Today we are mainly focused for our design for the zero materials at 0.8 millimeters. And the next topic, everybody's asking for halogen-free materials. We like to avoid corrosion in our final application. So therefore, halogen-free materials are mandatory to be selected. With halogen-free materials, we need to improve our design, we need to improve processing, and so on. So this flame retardant technology is not so easy to be integrated in the actual design standard instead of the semi-halogenated flame retardant systems which have been used maybe 2, 3, 4 years ago. Now everybody's asking for flame retardant materials. So regrind based on the actual situation. From the legal aspect, everybody likes to save CO2 emission. So therefore, we check in some cases if the carbon footprint and the global warming potential is reflected by the materials which you use. In some cases, this information is available by Plastics Europe or even from the resin supplier side. So we like to be as much as possible going with that trend, but we need to be careful. Also, when we select different materials, PBT versus polyamide, the carbon footprint rating is slightly different. The regrind potential is also slightly different based on the performance on the final application. So we have also a good relation to our plastic suppliers, being focused on renewable materials, but this is a topic which needs to be more or less agreed with the customer, because taking sustainable materials, renewable materials in our application versus standard ones, we need to know that the requirements are there. We need to fulfill with both material trends, the customer function, and at the end also the materials are much more expensive on the market. Somebody has to pay for it. Laser marking, we see more and more the trend moving from a standard laser marking process to a data matrix code performance, which says that the contrast on the part surface and the lifetime performance needs to be higher instead of that what was requested before. Combining that with color orange and flame retardant properties, this is not easy to be achieved. Laser welding is a topic. Pre-colored materials, as already mentioned, orange today is the black from the past. Therefore, in Europe, we are focused mainly for OEMs for RAL 2003. In other regions, maybe RAL 2004 or even 2008 are the main requirement for the colors for e-mobility. 2003 is a critical color instead of 2004 or even 2008. So therefore, we had a situation to improve the color performance over the last 2 or 3 years with our suppliers for HB materials with 01s plus laser marking. Thermal conductivity, if you have thermal peaks due to derating curves or even charger requirements, we need to have a material which is placed around the contacts where we have the highest thermal peak, which has some specific thermal properties to take as much as possible heat out of this section. Flowability, complex design of high voltage platforms, applications, different applications like connectors, like chargers, battery packages, and so on. Therefore, materials need to be good in flowability. So thermal improved materials. We have a lot of designs done in polyamide and PBT, but we see that in some areas we need to move from the standards like PBT polyamide up to high temperature nylons potentially, or even in some cases PPS. Silicons, based on the higher requirements on the high voltage application, we need to go with a silicon selection which is capable to pass thermal ranges in above 140 degrees C up to 160 potentially. Other requirements like topics with potting gluing, I would not like to go for the details. We lose maybe too much time. What we see also in the future, we see more and more 2K molding requirements, where we need to pre-select the materials which are flame retardant ones for the thermoplastic side, and we need to overmold in some cases the silicon, the silicons. So this will be a topic as an R&D discussion between the resin suppliers and silicon suppliers. So if I move forward for the next slide. Why this is not working? I'm not sure why. Sorry for this.
It was working before.
Yes, I know, but So the cursor is working, but the slides are not moving. Yeah. Do you change something on the surface potentially? I'm not sure why.
Yeah, I think Franz, you can eventually continue. Yeah, now it's working. Yeah.
Sorry for that, but if I have an issue with my computer, or even the line is not quite good enough based on the fact that I make the presentation from my desk. So when we select the material for high voltage requirements, we go over our customer requirements like mechanics, chemical requirements. In some cases, we have additional requirements like corrosion to be avoided. Therefore, we need to select a material which has maybe less humidity absorption, or even the flame retardant system. It's not critical to cause corrosion. What I like to be focused on this slide is we see the color orange in our parts. We have here the contact for high voltage requirements. We need to pass thermal test sequences up to 180 degrees C, up to 200 degrees C, and it could be if you select the wrong material, then we get more or less thermal stress on this finger protection, and it could be that the material was before black or even orange, and then we get a carbonization. So that means if you select the wrong material potentially, and we do the validation up to 200 degrees C, based on the thermal requirements from our customers, based on their validation spec, it could be that some materials like polyamide 6,6, they start to carbonize. Yeah. So therefore, we need a thermal robust system. In that case, we need also a better thermal stability of the materials, or even we need to select then high temperature nylons for this kind of application. For the surround parts, PA66 or even PBT materials, they are still okay from a technical perspective. Coming to the topic of orange, we had a lot of issues to be solved over the last 2 years. First, we had the combination for our parts. You see that in this color combination, where we had natural materials in place, and we had the use of master batches, also due to the fact that pre-colored materials in orange were not available on the market some years ago. We've had first the solutions, natural materials versus master batch coloring at the press. And in that case, if we had different suppliers based on the design, tool, design, machine, equipment, master batch dosage, we found out that we have a different color deviation depending on the part. And based on that, we said, okay, we like to improve the color situation with our resin suppliers, with our master batch suppliers. And then we made different tests. And at the end, decision was to move from a color solution with a master batch to a pre-colored material, which is then today our solution for RAL 2003. So requirements have been established, like no color sublimation, no migration, outgassing, if possible, not. We made some measurements on the CTI influence from the colors. We found out in some cases, depending on the pigments which have been selected, we do not have a real influence. In some cases, we have a drop for 50 volts or even more, depending on the color pigments, if they, based on the chemical structure. The color deviation part to part, as already mentioned, in this case, it's not allowed. So therefore, our intention was to have one solution in place, which is a pre-colored material. And at the end, we had to do some validation in our molding site, and we had to also to check the color performance over lifetime on the part. Conclusion and outlook. What do we see? As I mentioned already, we have a kind of test tool in place where we invite our resin suppliers and master batch suppliers to participate in our molding trials. So therefore, we like to check what is the difference between a material which is HB1 and compare that to V01. So we know that this will be never the case in the machine equipment or even in the tool site to have a similar performance for the zero material. So we need to be more tolerant on the effects which are coming from the colors and also from the flame retardant side. Yeah, as I already mentioned, we still have the focus to design parts in HB and V0 materials. We need to improve the laser marking performance on the parts. So therefore, we analyzed today the solution by adding some master batches for the laser marking of the additive package in the materials during the molding side. We go also in the test phase for pre-colored materials for laser marking. Therefore, we need to align the standards in the laser equipment and also in the verifier system. Our main topic, also reflecting our needs for the part validation over lifetime, is we need to have the same performance when we produce the parts, and we need to have the same performance during the test phase and also after thermal treatment when we end the validation process. This is impossible to be achieved. Therefore, we need more the participation from the resin industry to design materials which are more robust, having the same similar performance initial after molding in our lab, the tests which we need to do, and also what we see during the lifetime validation. As already mentioned also in the former presentation, we design mainly parts based on the test method CTR 600 volts. We have also an internal project already launched for 1000 volts. Means 1000 volt performance on the final application, but also reviewing the market trends, so which kind of test adaptations are available or will be available in the future. So therefore, we work together also over our global departments in different regions to improve the understanding what is behind 1000 volt. It's just the performance on the part, or even we could have potentially in the future also test standards in place which are giving us the confidence that if we select a material which is tested according to 1000 volt, this is sufficient to propose it in front of our customer. What we expect also today is we need more support from institutes like UL or even other ones comparable to that what UL is doing, to say that we need a standard in place with a test norm which is reflecting the materials based on the tests which have been done. So therefore 1000 volt is one of the topic, but also the material performance initially under test validation conditions in the lab, but also after thermal treatment. So we expect the dielectric strength to be measured after thermal treatment. We expect CTI values to be measured after thermal treatment, and also resistivity. Because if you compare polyamide versus polyester, then we see some differences there. So we need to conclude which is the better material candidate based on the specific requirement. V0 trends down to 0.4, halogen-free materials are still an important topic also in the future. And if you go for the thickness 0.4 plus halogen-free materials, we need to improve their thermal and mechanical performance. And in some cases, when we like to go for miniaturization, for example, for the battery packages, we need also materials in place with a lower glass fiber content. So this is potentially available from some suppliers, but this is not a standard today on the market. Flame retardant system, a request to the flame retardant industry. We need to be closer with them in alignments. What do we need to do from our molding perspective and also design perspective, and how different flame retardant systems are impacting the material performance on these two boxes, means molding performance versus final part requirements. And just to show the last point, we are placed for designs in high voltage connectors, charging inlets, sealing components, and battery design packages. And then I like to say thanks for the invitation, thanks for the questions which are coming later, and then I'd like to give the word back to Antonio.
Thank you very much, Franz. Despite all the small technical, let's say, difficulties, you have been able to finish. So that's a great achievement, and thank you for a very interesting presentation. Now we are going, initially we have been focusing more on what is inside the vehicle. Now we are going to move to a presentation which is telling us a little bit more about what is outside the vehicle, so about charging stations. And let me introduce now Nicolas and Laurent, who are going to talk about, let's say, the how to combine safety and fast charging into the stations. Please, Nicolas and Laurent.
Hello, thank you very much. Hello, everyone. So do you hear me and do you see my screen, firstly?
Yes.
Okay, thank you. So I'm Nicolas Dupont, the leader of continuous engineering for EG, who is also a plastic expert. So today we will talk about the safety aspect for the plastic selection for EV chargers. First of all, I will talk about the standard a little bit. So as you can see, we have two types of standard. One is for the charging station, and one is for the plug and socket. And for these two types, there is also different standard. So there is IEC for Europe and rest of the world, UL for North America, and SAE for Asia. So at the moment, we only target IEC because, of course, we only sell these products in IEC market. But later, maybe we will try to target UL, for example. And you can see it's still under harmonization. So the requirements for each standard are different. And that's why we only target one at the moment. So now I will talk a little bit about the chargers. So according to the IEC standard, there is 4 modes of charging. The first one, the mode 1, is not safe for Schneider because we can have overheating. It's just a simple plug, domestic plug. So we don't sell any products for mode 1. For the mode 2, it's the same but with communication, so it's more safe. The mode 3, we now have real classic EV chargers with dedicated power, dedicated cable and protection. And the last mode, the mode 4, it's for DC, so it's fast charging, and the 3 previous one were AC. As you can see, we have different types of socket depending of the countries. For Schneider, we mainly target mode 3, so in Europe, so the most common in Europe is type 2, but if we have fast charging, we can have more type of socket. Now, as you can see here, for the mode 1, for the first mode, you need a lot of time to charge the battery of the car, near a whole day. So it's very long, but for the mode 2 and 3, it takes between 7 hours and 2 hours, depending of how many power you have, if you are single or 3 phases. So as you can see, it's better because you can charge during the night, for example, every night. And the last mode, the quick charger, of course, it's below 2 hours, and this is just for the entry product, the 24 kilowatts. But with time, we can imagine that we will have 50 kilowatt or 100 kilowatt, and it will be very faster, and we can maybe have this in a station on the highway. So here is the overview of our actual product. The entry product is the wall box. So we can have an attached cable or not. It's for indoor or outdoor. It's very easy to use because there is just a start and stop button, and it's quick to install. We have 2 plastic cover envelope for a better IP and IK. We can have a K-lock. There is a little energy management to defer the start or the charging current limitation. And we can put it on the wall or on a pedestal like this. The evolution of the wall box is a smart wall box, so it's a communicated product. The first one was residential. This one is semi-public or for condominium, for example. We have RFID authentication with badge. It's easy to commission with a laptop. And also, we can have a backend connection via OCPP. So for the CPO, charging point operator, it can manage the wall box. So if the CPO wants to manage many wall box, it can buy this LMS. It's a small computer that can manage from 5 to 100 charging stations. You will have a management of the authorization and access and a dynamic load management. So it's very useful if you have different wall box at the same point and you don't have enough power for every wall box. You need this LMS to linearize the power. The last product for the AC product range is the parking. Now we can have 2 charging points on the same unit. So all of these products are mode free, but you can also have option with domestic socket, so also mode 2. Now it's not plastic, but it's metal enclosure. And you can have it on the floor or on the wall, and you can put the protection inside if you want. And there is also some energy management. So all of our products here are compliant with Green Premium. I will explain a little bit later, but it's an internal policy, eco-friendly. Now concerning the DC products, at the moment we only have the 24 kilowatt. It's just above the smart wall box that can be 22 kilowatts. So it's a little bit faster, it's more robust, it's the cheapest solution for DC. It's easy to install. As I say, there is also more type of socket. And we will certainly develop this product range in the future. So now I will talk about the main topics here. The plastic selection. So I will make 2 slides. The first one is for the plastic of the charger. So here are all the requirements for the IEC standard. So the first one is the IP. The standard only required IP44, but as our product is outdoor, we have IP54. Now we have also a low temperature. One of the key requirements is the glow fire, but as you can see, it's only 650 degrees, so it's not so difficult. After that, we have the marking durability. We have also the REACH and ROHS requirements, and with our internal policy, we want halogen-free material with Green Premium. Another key requirement is the IK 8. So it's a minimum, but all of our products are tested for IK 10. And for me, the last main requirement is the UV resistance. So there is a UV test method in the standard. And we have also a requirement for electronic safety. So with all of that, we choose a PC UV stabilize. It's a cost-effective technical solution. So as you can see, it's a pretty common material, and it's not so difficult to find the good material for this standard. Now, as you can see, there is a little difference between the previous standard for the charger and this one for the cable and the socket. So as you can see, the IP and environmental requirements are a little bit harder. Also for the low temperature, and we also have a high temperature. Even for the glow fire, you can see that the requirements increase a little bit. For each ROHS and marking durability, it's the same. Now we have this famous IK10, and we still have some electric requirements, of course. So as you can see, it's a little bit more difficult to find the good material for this one, but our first one material was compliant with both anyway. And so now I will let Laurent talk about UL, and you will see that there is more requirements for UL, of course.
Okay, thank you, Nicolas. So in the previous slides, we have seen in detail the technical requirement listed in the IEC standard for safety and reliability of charging station enclosure and plug-in sockets. But the situation is slightly different in the UL standard. And we decided to focus on the flammability specified in the UL 2594 and the UL 2202. So as you can see in this table, while the rating are not very high for internal part or external component, both the movable and permanently installed enclosure should reach 5E rating. And this rating is definitely most stringent rating for the UL 94 flammability test. It consists in the application of a burner which is 10 times more powerful than the usual burner which is used for V1, V2, and V3 rating. And moreover, the flame is applied 5 times instead of 2, and the combustion should stop before 60 seconds without any flaming droplets. So this rating can be achieved only with flame retarded polymer, and consequently the enclosure which has been developed for IEC compliance cannot be directly used for the US market. In the UL 2202, it's even worse because there is an additional test which is required if the enclosure has at least one dimension which is exceeding 1.83 meters or a projected surface larger than 0.93 meters square meter. This test can be either the Steiner tunnel test or the radiant panel, but in both cases, the flame spread rating should remain lower than 200. So as a conclusion of this presentation, we have seen that several standards apply on the EV charging station and plug-in sockets, but there is a lack of harmonization, and the UL requirements for flammability are significantly more stringent than the IEC. Halogenated or non-halogenated flame retarded material are required for the UL, while they are not necessarily required for the IEC. And then the IEC requirement should be also achievable with recycled material, which is a huge topic within Schneider. We are pushing a lot for renewable material or green material. And we are thinking about the possibility to include more and more recycled material in our offer, including the EV charging station. So I would like to thank you very much for your attention, and do not hesitate to ask some questions during the Q&A. Thank you.
Thank you very much, Nicolas and Laurent, for the very interesting and very comprehensive presentation about key critical points and standards for the charging stations. Now, last but not least, of course, I let Mr. Adrian Bird introduce himself, in a sense that he already had a good introduction of himself, and Adrian will talk for the last presentation is about environmental impact and sustainability of flame retardant systems. You heard by many of the presenters talking about sustainability, which is going to be one of the hot topics also for the European community for the next 50 years. So definitely hearing a little bit more about sustainability from, let's say, producers of additives for the plastics and for the chemical industry is very, very important. Thank you, Adrian, and please go ahead.
Yes, thanks very much, Antonio. You can see my screen, I hope.
Yes.
Okay, very good. So Yes, thanks for the kind introduction. I want to give you a very brief overview of current topics in environmental topics and sustainability issues around flame retardants. And as we heard before in the previous speeches, there is a trend towards replacing halogenated flame retardants with halogen-free flame retardants based on phosphorus, inorganic, or nitrogen chemistries. And to briefly explain, Antonio introduced me earlier, so I'm with Clariant, and I'm presenting here the Clariant point of view and also some examples, but there is also, of course, a strong relation to PINFA, and my background is, as also mentioned earlier, environmental sciences, and then moving into chemistry and business topics. So hopefully moving on, yes. As PINFA, we have a shared vision on what flame retardants should look like and what properties they should have. And already in 2009, when PINFA was formed, we put in our even statutes the concept of an ideal flame retardant, which means, of course, it must be fit for purpose. It must achieve the flammability requirements, ratings that are requested, but it should also be non-toxic. Risk and hazard should be controlled. It doesn't mean that no hazards are possible, but hazards that the chemistry may pose should be well controlled and well known. It should not migrate out of finished products, should not contribute to release additional toxic or corrosive gases in case of fire, should not impede the recycling of finished materials. As Laurent just mentioned, recycling is becoming more and more important these days. And ideally should be degradable in the environment or remains neutral as naturally occurring substances. For instance, when you think of aluminium hydroxide, the aluminium will not degrade. It's a chemical element, it's a metal, but it should not have any detrimental impact in the environment. So this was our vision, and we want to work as PINFA members towards that, realizing that this is a set of targets that are not easy to achieve, that are not completely achieved with today's materials that we have, but the idea is to work towards those. And also we want to maintain, of course, high fire safety standards across the world, which minimize the risk of fire to people, the general public, and also impact on assets. Yes, a very recent topic for chemicals, not flame retardants in particular, not flame retardants alone, but chemicals in general, is the chemical strategy for sustainability that was released by the European Commission just about 2 weeks ago, October 14. And that is a program to look at the impact of chemicals on humans and the environment as part of the Green Deal that the European Commission has launched. It relates to buzzwords like toxic-free environment as one of the building blocks of this Green Deal, and it will open existing legislation like REACH, the topic of how polymers are dealt with under REACH, for instance. It will look at endocrine disruptors, it will look at fluorinated substances, and many more. There's a whole list of topics they want to look into, and it will certainly also affect flame retardants and how flame retardants will be regulated. It's early stages. I just wanted to give you a hint to the fact that this is something emerging, and then people are saying it could be even bigger than REACH, which came into force in the early 2000s and was, say, initiated around about the year 2000. So this may be something of a similar dimension that may change the chemical industry and how we approach safety of chemicals. Yes, when you look at sustainability of chemicals, there are 4 dimensions that are becoming more and more important. On top here you see climate neutrality, so greenhouse gas emissions, zero pollution from production and processes, also the topic of non-toxic, safer chemicals also for the consumer in use, and as already mentioned, circularity, so being able to recycle materials, have closed circle of materials and products or product parts. So all these topics are now becoming very dominant or prominent, and as a flame retardants industry, we have to and need to address all of those. There are regulations in place and restrictions on flame retardants. I just highlight here a few because going into more details would take a lot of time. So several flame retardants have already been restricted under legislation like REACH in Europe. The buzzword there is, one of the buzzwords is substances of very high concern. The restriction of hazardous substances in electric and electronic equipment, or the United Nations Persistent Organic Pollutants Program. And the restrictions so far have been mainly for halogenated flame retardants, but also phosphorus-based and others have been affected. There are some examples. So watch this space. Restrictions do not happen overnight. They have quite some lead time when substances are assessed. So as also a downstream user, if you watch what is happening in these discussions and communities, you get a feel for what might be coming there. Yeah? I already mentioned the ROS directive, not directly applicable to cars, but I think when we saw the tests earlier mentioned also by UL, glow wire test, yes, is a car seen, an electric car, is that an electric appliance in a way? Can you regard it as that? So currently not affected, but this may also be what is coming in the future. Flame retardants that had been recently evaluated were tetrabromo bisphenol A, medium chain chlorinated paraffins, and antimony trioxide, where some issues were identified and discussed. And here you see the reference where you find more information. Or the eco-design directly for electronic displays that restricts halogenated flame retardants in housings of displays as of next year. So there is a lot happening around flame retardants and their regulation. Also, beyond regulation, there are things like eco-label voluntary requirements that put either restrictions on the use of certain flame retardants, often halogenated flame retardants, or you get even a bonus, or you get points for using halogen-free materials or using materials that have been well assessed. For instance, TCO development here, they have a positive list of flame retardants that they allow to be used in their products. So this is the list of flame retardants accepted under TCO. Similar things might also happen in the area of the automotive industry. It's early times, but I think the consumer electronics and electronics industry has been really leading in this area, and may be important to watch this space for what might also happen then in the area of white goods, household appliances, or even automotive electric vehicles. Yes, we heard a lot about the challenges for flame retardants in electric vehicles, also the opportunities, because the use of engineering plastics that require flame retardants has been increasing, as was shown also in earlier presentations. What has the flame retardants industry been doing about this and about sustainability impact? Here an example from Clariant. Our brand name for our flame retardants is Exolit, and the Exolit OP Terra types are type of phosphonate-based flame retardants that we are introducing into the market that are based on renewable carbon sources. And with that, we can show that the carbon footprint can be lowered by about 20% of the flame retardant. And this reduction by 20% is because the raw materials, and that has the main impact, their carbon footprint is reduced by around about 18%. We have been using green energy at the production site here near Cologne in Germany. So the carbon footprint of the energy itself consumed has been reduced by 2/3. And overall, the operations on site have also reduced their carbon footprint. So an example of what the chemical industry can do and has been doing to address, for instance, the question of climate neutrality and climate change. Or another example, again from Clariant, to have programs in place to evaluate our portfolio, not only the flame retardants, but all our portfolio within Clariant with regards to environmental and health impacts and performance. And the best in class, they receive this Ecotane label that you see here. And below you see the phosphonates that have achieved this not eco-label, but internal, something like an eco-label. Which is based not only on hazard properties, but a range of more than 30 criteria that also look into things like greenhouse gas emissions, like wastewater, and social impacts, and the big also difference to other assessment schemes is that this one compares existing products or the product in question to the market benchmark or other products in the market. That's important because for some chemicals, of course, they have certain properties because they are needed or necessary for the function or inherent. So there you have to compare like for like. And what's also important in the area of flame retardants is to have third-party assessments of environmental and health properties. And here on the right-hand side, you see some examples where our products have been assessed by like the German EPA, Umweltbundesamt, US EPA, European research projects, Fraunhofer Institute, and so forth. And also Green Screen, an assessment scheme for chemicals where these products have achieved the benchmark 3, which is a best in class for flame retardants. There's only one benchmark above, benchmark 4, which even water and sugar might have difficulty to achieve. Yes, so already coming to my conclusion. Yes, restrictions of flame retardants by legislations and eco-labels drive transition to halogen-free flame retardants in many areas, including e-mobility. Industry, so the flame retardant producing industry, is doing a lot to reconcile fire safety and environmental profile and properties. We are participating in product assessments, carbon footprint assessments, studies on recycling properties. Also, within the scope of PINFA, we have been approaching this topic. We collaborate on positive lists of flame retardants based on clear criteria that are based on assessments and scientific judgment. And one example of this is, as I just mentioned, this Clariant's portfolio value program. And what we heard in earlier presentations, that on top of that, performance requirements for flame retardants get more and more demanding. And I've been saying in the past in many presentations that to achieve the flammability rating that's required is not the most demanding challenge. The most demanding challenge in developing a flame retardant or flame retardant formulation is to combine the flame retardant performance with all the other parameters and material requirements that are necessary and that were also mentioned by previous speakers, be it color stability, be it mechanical properties, electrical properties. All of these things make it really challenging to develop state-of-the-art flame retardant polymer formulations. So with that, I come to the end of my very brief overview. Thank you very much for your attention. I will make available after the event a more detailed version of this presentation where you find more references and more detailed text, but I just wanted to keep it very short for this webinar to just give you a glimpse and an idea of what the current topics are and how we are addressing them. Thanks very much, and back to you, Antonio.
Thank you very much, Adrian. And we are almost close to the conclusion of our webinar. Unfortunately, we are a little bit beyond the initial schedule for which concern the, let's say, timing. So we have only space for a couple of questions, just probably 2 or 3 questions. And while the questions will come, I have a question for you, Adrian, particularly concerning we mentioned about the new regulation, new tests which are going to come. So how do you see, which are the main challenges for the sustainability of flame retardant in the future? And how PINFA as association is addressing this kind of issues?
Yes, let me just mention 2. And I think one that I mentioned in my presentation, others mentioned is recycling. Recycling of polymers that contain flame retardants it's not brand new, but it has been around for some time, but it is not really resolved yet. And then there's the question of mechanical recycling, to what degree is that possible, or do we also need to consider, and that's my opinion, need to consider chemical recycling, so depolymerization, separation of flame retardant from polymer maybe. So we need to look into new technologies to be able to really close these circles. So that's a big challenge. And PINFA is also engaging in projects, for instance, with the Fraunhofer Institute, LBF, on this topic. Another big topic for flame retardants, also in the context of this chemical strategy for sustainability, is the topic of persistence, which is becoming more prominent in the discussion around chemicals. For flame retardants, persistence is not a bug or a failure. It's a feature. It's a feature that is necessary for the long-term functioning of the flame retardant in a product. And it's also a necessary feature for processing the flame retardant in engineering polymers that are treated at or processed at high temperatures. So I think it's more important to educate and to discuss with authorities why, in this case, chemical stability is really necessary, and that you cannot give us flame retardants bad marks because we have this persistence property. Of course, it must not have a negative impact on the environment. Okay, thank you. I see that there were a couple of questions also coming and some people raising the hands. Unfortunately, we don't have time because this is already the end of our call, so I apologize for this, but please send your questions via email and we will try to answer the best we can. Having said this, we thank you very much for your participation. And again, sorry for not having enough time for the question and answer session. And hopefully see you in the next webinar from PINFA. Thank you very much. Thank you. Bye-bye.
Thank you.
Bye-bye.
Nice day.
Nice day. Awesome.